Hello, let us learn about angles of elevation and depression. So, assume that if we are standing here and we are looking at a flower which is on the tree, on one of the branches of the tree, and it is obviously like the height of the tree would be greater than us. So, like we will be looking upward. So, angle of elevation is what? Angle of elevation is like if I draw a horizontal line here, okay, so my angle of elevation would be this, okay, this would be my angle of elevation, okay, angle of elevation would be this. Then angle of depression would be what? Like if a bird is sitting here on this flower, or a butterfly is sitting on this flower, and that butterfly is watching you downward, so the angle of depression would be this angle, okay, this would be angle of depression, right? So angle of depression is like saying downward. When we see downward, then that angle of depression, we have to make a horizontal line and then we can find out that angle of depression. Or angle of elevation would be when you are looking upward. Fine. Now let us do some questions based on angles of elevation and depression. So one very simple question I have taken. A boy is flying a kite from a string of length 150 meter. Okay. A boy is flying a kite of length string with a string of length 150 meter. Now if the string is towed and makes an angle of 67 degrees with the horizontal. Fine. So boy is say from here a boy is flying a kite, so must be like at some angle, right? This way. The string would be this. This is the string and the length of the string is 150 meter, and boy is standing here, right? So this way he is holding the string, you can say, okay. And now this is making an angle of 67 degree with the horizontal. String is making an angle of 67 degree. It means that this angle is given to be 67 degrees. Now they are asking you what is the height of the kite. So kite is here, so height of the kite would be what? The height of the kite would be this. So we have to find out this height. Now see, this angle is 67, this angle is 90 degree. So the opposite to angle 67, this is my opposite side, and then opposite to 90 degrees 150 meter, this is my hypotenuse. So which ratio I will use? I will use so katwa, means so, that is sine. So I will write sine of 67 degrees is equal to opposite side, let us name it as x, equal to x over hypotenuse, which is 150 meter. Okay, let us write here sine theta is equal to opposite over hypotenuse. So my x would be what? This would be 150 times sine of 67 degree. Now the task is to use our calculator quickly. So let me use it. 150 times sine of 67 degree. So the kite is 138.075 something I'm getting. So I can say 138.1 meter above the ground is my kite. Clear? So this way we will use trigonometry to use a simple question like this. So 67 degrees the angle of elevation here given, right? Because kite is above the ground. Okay, so 67 degrees angle of elevation. Hope you understood. Now let us solve one more question, right? Let me move this question a little up so that we can get more space here. Yeah, here we are. Fine. So now this question seems to be little. Let us read first. The angle of elevation of the top of the tower is 27 degree. This is the angle of elevation of top of the tower, 27 degree, from a point A due east of it. Okay. and the angle of elevation of the top of tower is 11 degree from another point B, which is due south of the tower. Okay, and then they are asking us to find the height of the tower, and the distance AB is given to be 40 meter. Okay, the very first thing which we will do is we will make the diagram. So top of the tower we have to find out we have to find out the height of the tower. So let us draw the tower first. I am making the tower here. Okay, let this be our tower. Now they are saying this is my top of the tower, and the angle of elevation of top of tower is 27 from a point A due east of it. So maybe some point A here, and the angle of elevation from this point is 27 degrees. So this angle, it means like with this horizon or ground or horizon, let us say, this angle is 27 degrees. Let the height of the tower be h. Let height of the tower be h. Now next what they are saying, the angle of elevation of top of the tower is 11 degree from another point B due south of the tower. So south means south would be down, right? So here if I take B point and the angle of elevation, so I will make like this, okay, and this way, and then I can complete my triangle here, and then this also I can join by dotted line, or I can like join it directly. So let me join it directly. Okay, yeah, so just try to imagine this thing. So this is A, B, let me write here something as C, here D, right? So angle of elevation of this angle, imagine this angle is 11 degree. Okay, this ABC is actually a plane. It is a plane, okay, which is pointing towards us. Fine, which is pointing towards us. So that way you imagine the angle DCB is actually 90 degrees. So if I draw it again here, so you can imagine this way. This is DC and this is B. This is angle 90 degree and this angle is 11 degree. Got it? So this is DCB triangle, and another one is our ACD triangle. That is simple ACD, and here this angle is 27 degrees. In both the cases height is same. Clear? Okay, now let us assume wait, let me choose some different color. Now let us assume this side to be X and this side to be Y. Okay, remember ABC is also this thing, what? Right angle triangle. Okay, now let us apply. AB distance is given to me. AB is 40 meter. Let us note here. AB is 40 meters. Fine, AB is 40 meter. Now we can apply our Pythagoras theorem in triangle ABC. So in triangle ABC, if I apply Pythagoras theorem, I can say x square plus 40 square is equal to y square, because y is the hypotenuse here. See, this is opposite 90 degree. So let us save this thing. Now coming to this triangle ACD. In triangle ACD, that is this triangle, if I apply, I want H, I write 1027 degrees. See, because this is opposite side, actually this is opposite side and this one is my adjacent side, correct? So if I apply here 10 of 27 degree, to a 10 theta to a, right? So 10 theta is equal to opposite over adjacent. So 10 of 27 is opposite, which is H, over adjacent, which is AC, and AC is what we have written, AC as x, so I can say it this way. So I can say that H is equal to x times 10 of 27 degree, right? We can say that way. H is x 10 27 degree. Now we can apply in same thing like in triangle, DCB triangle. If I apply the same, then this is 10 and I will write 10 of 11 degree will be, see, this is my opposite side, this is my adjacent side, correct? This is my adjacent side BC. So I can say this is H over BC, and H over BC is what we have taken BC as Y. So I can say from this that H is equal to Y times 10 11 degree. Clear? So from here now I can write my I can use how much is 10 27 degree. So 10 of 27 is 0. Let us write here, this is 0.5095 something x, and here H is your 10 of 11, so this is 0.19438, so 0.1944 y here. Okay, this is H and this is here H. Fine, we have got this. Or we can now do one thing, we can write our x in terms of H and then substitute here. That would be much better. So what I can write is, I will write it this thing or this thing. Okay, so I can say that my x is actually H over 0.5095, or if we do not use the values here, we can simply write that x is equal to H cot 27 degrees and y is equal to H cot 11 degree, because my cot theta is equal to 1 over 10 theta. Okay, and then I will use these in my first equation, x square plus 40 square is equal to y square. Let us use it here. X square, which is H square cot square 27 degree plus H square cot square 11 degree is equal to, oh no, 40 square we were supposed to write here, sorry. So 40 square is 1600 is equal to y square, which is H square cot square 11 degree. Okay, so now we can take here, so H square is this common 27 degree minus cot square 11 degree is equal to negative 1600.